Article 250.119d of the National Electrical Code, NEC, allows the use of tape to identify grounding conductors in specific situations. Bare or insulated conductors shall be permitted to be permanently identified as grounding conductors by means of green tape or green marking paint at each end and at every point where the conductor is accessible. In the situation of using insulated No. 4 American wire gauge stranded copper CDR as a grounding conductor, several points support the acceptance of using green tape for identification. Firstly, the grounding CDR will be accessible on the exterior of the building and through joists in the interior. Secondly, green tape is a clear and permanent way to identify the conductor as grounding, especially since the THHN insulation is black. Thirdly, Article 250.119d permits the use of green tape for identification of grounding conductors that are not bare. This practice may have been historically accepted. This suggests that it has been deemed compliant with the NEC by local authorities. There are some additional considerations to think about as well. Ensure that the green tape is applied securely and in sufficient quantity to prevent removal. Avoid wrapping the tape too tightly, as it can damage the conductor insulation. Consider using a heat shrink tubing with a green stripe as an additional layer of identification, if desired. Based on the NEC and the specific circumstances of the installation, the use of green tape to identify the insulated grounding CDR is acceptable. This practice is clear, permanent, and consistent with electrical code requirements. The key to understanding the code's allowance for using green tape lies in the principle of accessibility. The code emphasizes that the green tape or marking paint must be applied at each end of the conductor and at every point where the conductor is accessible. This accessibility requirement ensures that anyone working on the electrical system can easily identify the grounding conductor regardless of where they encounter it along its run. The NEC recognizes that in many situations, it may be impractical or unnecessary to use a green insulated conductor for the entire length of the grounding wire. Using green tape provides a practical and cost-effective alternative, especially when dealing with long runs or when the conductor is already in place. Furthermore, the use of green tape aligns with the NEC overall goal of promoting electrical safety. By clearly and consistently identifying the grounding conductor, the risk of accidental contact with live wires is reduced and the potential for electrical shock is minimized. The NEC allowance for using green tape is not without its limitations. The code specifies that the tape must be green in color and that it must be applied in a manner that is permanent and readily visible. This means that the tape must be durable enough to withstand the environmental conditions to which it is exposed, and it must be applied in a way that prevents it from peeling or fading over time. In addition to these requirements, it is important to ensure that the green tape is applied correctly. This means that the tape must be wrapped tightly around the conductor, and it must be overlapped to provide a secure and reliable connection. It is also important to avoid wrapping the tape too tightly, as this can damage the conductor insulation and compromise its ability to provide a safe and effective ground. While the NEC allows for the use of green tape in certain situations, it is always a good idea to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable codes and regulations. These professionals can provide guidance on the proper selection and application of green tape, as well as other grounding techniques. They can also help to identify any potential hazards or code violations that may exist in the electrical system. In addition to the NEC, there may be local codes or regulations that govern the use of green tape for grounding conductors. These local requirements may be more stringent than the NEC, and they may impose additional restrictions or limitations on the use of green tape. It is important to be aware of these local requirements and to ensure that the installation complies with all applicable codes and regulations. The NEC is updated every 3 years. It is important to stay up to date on the latest changes and revisions to the code. These updates may include new requirements or clarifications regarding the use of green tape for grounding conductors. By staying informed about the latest code changes, it can be ensured that the electrical installations are safe, compliant, and up to date. In summary, The NEC allows for the use of green tape to identify grounding conductors in certain situations, provided that the tape is applied correctly and that the installation meets all applicable codes and regulations. This practice provides a practical and cost-effective way to ensure that grounding conductors are clearly and consistently identified, which helps to promote electrical safety and prevent accidents. The allowance for using green tape on grounding conductors as per NEC 250.119d balances practicality with safety. It's not just about slapping some green tape on a wire, it's about ensuring a clear, permanent, and accessible identification of the grounding conductor. Think of it this way: the electrical system is like a complex network of roads, and the grounding conductor is like the emergency lane. It needs to be clearly marked and easily identifiable so that in case of a fault, electricity can quickly and safely find its way back to the source, preventing shocks and fires. Now, why not just use green insulation all the time? Cost is a major factor. Insulated green wire can be more expensive than using a standard black insulated wire and marking it with green tape. For long runs, the cost difference can be significant. Also, in some existing installations, it might be easier to add green tape to an existing conductor than to replace the entire wire. That being said, the NEC doesn't just let you use green tape willy-nilly. There are rules to follow. Firstly, accessibility. The green tape needs to be applied at each end of the conductor and at any point where the conductor is accessible. This is crucial. Imagine someone working on the system years later. They need to be able to quickly identify the grounding conductor without having to trace the entire wire. Secondly, permanence. The tape needs to be durable enough to withstand the environment it's in. Cheap tape that peels off after a few months is useless. Use high-quality electrical tape that is designed to last. Thirdly, proper application. The tape needs to be wrapped tightly and securely around the conductor. Overlap the tape to ensure good coverage. Don't just wrap it once or twice and call it a day. Fourthly, color consistency. The tape needs to be a consistent shade of green. Faded or discolored tape can be confusing. If the tape starts to fade, replace it. Here is a practical example. Imagine running a grounding conductor through a series of joists in a building. You would need to apply green tape at each end of the conductor where it enters and exits the joist bay. This ensures that anyone working in that area can easily identify the grounding conductor. Now let's talk about some common mistakes to avoid. One common mistake is using the wrong type of tape. Don't use duct tape, masking tape, or any other type of tape that isn't specifically designed for electrical applications. These tapes can dry out, crack, and lose their adhesive properties over time. Another mistake is not applying enough tape. Make sure the tape is wrapped tightly and securely around the conductor with sufficient overlap. Don't skimp on the tape. Another mistake is wrapping the tape too tightly. While the tape needs to be secure, avoid wrapping it so tightly that it damages the insulation of the conductor. This can compromise the safety of the system. Another mistake is not checking the tape periodically. Over time, tape can become damaged or discolored. Inspect the tape regularly and replace it if necessary. So, to sum it all up, using green tape to identify grounding conductors is an acceptable practice under the NEC as long as you follow the rules. Remember accessibility, permanence, proper application, and color consistency. Avoid common mistakes like using the wrong type of tape, not applying enough tape, wrapping the tape too tightly, and not checking the tape periodically. By following these guidelines, ensure that the electrical systems are safe and compliant. The NEC permission to mark grounding conductors with green tape isn't a free pass to cut corners. It's a carefully considered allowance that balances cost, practicality, and safety. It's up to the electrician to understand the rules and apply them correctly. Think about the implications of a poorly identified grounding conductor. In a fault situation, the electricity might not be able to find its way back to the source quickly enough. This can lead to overheating, fires, and electrical shocks. It's not worth the risk to save a few cents on tape. Now let's talk about some advanced considerations. In some situations, it might be beneficial to use green heat shrink tubing instead of green tape. Heat shrink tubing provides a more durable and professional-looking finish. It also provides additional insulation and protection for the conductor. Another option is to use pre-printed labels that specifically identify the conductor as a grounding conductor. These labels can be applied to the conductor in addition to or instead of green tape. When working in corrosive environments, it's important to use tape that is specifically designed to withstand those conditions. Some tapes are resistant to chemicals, moisture, and ultraviolet light. Another consideration is the size of the conductor. For larger conductors, you might need to use wider tape to ensure adequate coverage. Another important point to consider is documentation. Keep a record of where and when green tape was applied. This can be helpful for future maintenance and troubleshooting. Consider adding a note to the electrical panel schedule indicating that green tape was used to identify the grounding conductors. In some cases, it might be helpful to take photos of the installation before closing up walls or ceilings. This can provide a visual record of the grounding conductor and the location of the green tape. Remember, the goal is to make it as easy as possible for anyone working on the system in the future to identify the grounding conductor. The information provided here is for general guidance only. Always consult the latest edition of the NEC and local codes for specific requirements. If you're not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, and it's not worth the risk to try to do it yourself if you don't know what you're doing. Here's a breakdown of the key elements to ensure proper identification using green tape. Firstly, conductor type. Verify the conductor is suitable for grounding purposes, typically copper or aluminum. Secondly, tape quality. Use electrical-grade green tape that is durable and adheres well to the conductor. Thirdly, application technique. Wrap the tape tightly and securely around the conductor with sufficient overlap to ensure complete coverage. Fourthly, location marking. Apply the tape at each end of the conductor and at every point where it is accessible. Fifthly, visibility. Ensure the green tape is clearly visible and not obscured by other components or materials. Sixthly, code compliance. Adhere to all applicable requirements outlined in NEC Article 250.119. DN any local codes. Seventhly, inspection. Regularly inspect the tape for damage or deterioration and replace it as needed. Eighthly, documentation. Maintain records of the location and application of green tape for future reference. Ninthly, safety precautions. Always to energize the circuit before working on electrical conductors. Tenthly, professional consultation. If unsure about any aspect of grounding conductor identification, consult with a qualified electrician. Remember that using green tape is a practical and code-compliant way to identify grounding conductors. By following these guidelines, one can ensure the safety and reliability of the electrical system. Consider the broader context of grounding within electrical systems. Grounding isn't just about preventing shocks, it's about creating a safe path for fault current to flow back to the source, allowing overcurrent protection devices like circuit breakers to trip and clear the fault. A properly grounded system protects equipment, reduces the risk of fires, and saves lives. Grounding systems come in various forms, including equipment grounding, system grounding, and grounding electrodes. Each type of grounding serves a specific purpose in ensuring the overall safety and performance of the electrical system. Equipment grounding connects non-current carrying metal parts of electrical equipment to ground, preventing them from becoming energized in the event of a fault. System grounding connects the neutral point of a power system to ground, stabilizing the voltage and providing a reference point for fault detection. Grounding electrodes, such as ground rods or ground plates, provide a direct connection to the earth, dissipating fault current and minimizing the risk of electric shock. The NEC provides detailed requirements for grounding systems, covering conductor sizing, installation methods, and bonding techniques. It's essential to follow these requirements carefully to ensure that the grounding system is effective and compliant. Common grounding mistakes include using undersized conductors, failing to bond metal enclosures properly, and neglecting to test the grounding system periodically. These mistakes can compromise the safety of the electrical system and increase the risk of electrical hazards. Regular inspection and testing of the grounding system are crucial to ensure that it is functioning correctly. This includes verifying the continuity of grounding conductors, measuring ground resistance, and inspecting for signs of corrosion or damage. By addressing any issues promptly, it is possible to maintain the integrity of the grounding system and prevent potential problems. Grounding is a critical aspect of electrical safety, and it's essential to understand the principles and requirements involved. Whether one is a homeowner, electrician, or engineer, a solid understanding of grounding can help to prevent electrical accidents and ensure the safe operation of electrical systems. Take the time to learn about grounding and to implement it properly in all electrical installations. The safety of people and property depends on it.